Please don't lose that.
I won't lose it, I just won't get it.
We're gonna jump into the next section. It's another shortcut for finding derivatives. It's called product rule, and you use it when you're finding the derivative of a function that's a product. Yeah, I know it's kind of deceptive the way they name it sometimes. But what is a product in math? Two things being multiplied? Yeah. So if you've got a function times a function to make like a bigger function, and that's what you need to differentiate, then you want to use this happy fella here. It's kind of weird calling these shortcuts, and they are shortcuts, but it's like we never had to differentiate a product using limit definition. So it's like sometimes these shortcuts actually end up being not like 8-step problems, but like you get more complex answers than like 4x, you know. And the reason is because we're using shortcuts, but we're using more complicated functions, so the answers might look more complicated than they would if we were using limit definition on some of these, it would just be like that. I wouldn't even want to do it.
What?
I know.
Wow.
You need a 3-course meal and Snickers for dessert. So obviously we're going to use product rule when differentiating products.
I think you really like Snickers.
I'm allergic to nuts.
No, not allergic, I just don't like them.
Okay, is you don't even like Snickers?
No.
No.
Three Musketeers I'm fine with. Hershey's, I have no problem with Hershey's.
Marshmallows?
What?
What?
Where's that about?
Peanut butter. What? Aren't there marshmallows?
Anyway, the derivative of something like the derivative of something like f of x plus g of x is quite simply f prime of x plus g prime of x. So take the derivative of the first term plus the derivative of the second term. That's kind of what we've been doing. But, just like in Pee-wee's Big Adventure, when he's on the truck with the truck driver lady, so he's hitchhiking, the truck driver lady's name's Large Marge, and she's telling him his life story. And she's telling him the story, he's like, and then she gets to a point, she goes, but, and he goes, oh, because, you know, something bad's coming, right? But he goes, everyone I know has a big butt. But the derivative of f of x times g of x is not f prime g prime. Hi. Thanks. There you go.
I know, because like 3 things was possible.
So with limits, you can do that. With limits, if you got the limit of 2 things multiplied, you can take the limit of each thing and multiply the results. But with derivatives, it doesn't work so well.
Does that apply for division?
Yeah, you can't do derivative divided by derivative, won't work, and that's quotient rule, and we'll talk about that tomorrow.
Can you use subtraction?
Well, addition and subtraction you can do. If it's term, how about that? If it's a term and then a term, you can go ahead and break up the terms. Alright. So for that, we have the product rule. Here's what the product rule looks like. Product rule, the derivative with respect to x of f of x times g of x. You want to do the first thing times the derivative of the second. So f as it's written times the derivative of the second part of the product, plus, and then you come back the other way. By that I mean, keep the second part of the product as it is, and guess what you multiply that by? F prime, the derivative of the first part. So it's kind of weird that you start out with one term in the function, but get two terms in the derivative. But that's just the way it is. And then, so this is for two terms. If you, hypothetically, if you had f times g times h, a third part of the product, guess how many terms would be in your answer? Not that bad.
4.
If you had three factors in the function, you'd have three terms in the answer.
Someone guessed 3 and you didn't say yes.
Yeah.
I didn't hear that though, you see, because sometimes all I hear is when it's quiet to you, that's what I hear. If you had a third factor, h of x, you'd have three terms in your answer, and each one would take turns being the derivative. So then you'd have f g h prime plus f g prime h plus f prime g h. If you had 6 factors, you'd have 6 terms, and each term, one of those factors would take its turn being the derivative. But in general, you're not going to see that. In general, you're going to see just 2 factors in your function. For example, then, we want to find f prime of x if f of x is 3x cosine x. So this is a product. What's that? That'll be part of it. Let's kind of define what we've got for pieces here. We could look at, I mean, there's a 3 that's a constant we could pull out, or you could just, I like to group the 3 in with one factor or the other. So we've got 3x is one factor, and we got cosine x is another factor. So when we differentiate it, we're going to take it says take the first factor times the derivative of the second. So what's the first factor? 3x times the derivative of the second part. Yeah, derivative of cosine x we were talking about yesterday is negative sine x. Yep. Plus, now we've got to come back the other way. So now we take the second factor as it's written. Yep. Times, excuse me, times the derivative of the first. Well, what's the derivative of 3x?
3x.
Well, it's actually just going to be 3, right? It's like 3 times x to the 0. So that's, and honestly, we can clean this up a little bit. There's going to be a negative coefficient out for it. This isn't 3x minus, this is 3x times negative. So I'm just going to throw the negative sign to the front of the term. And then we got 3x sine x. I'll throw the 3 here out front of the term. 3 cosine x. That's the idea.
So what's the like that's going to factor out like a negative 3?
You could factor out the 3 if you do, if you don't. it's all the same. I mean,
That's great.
another example, perhaps.
Yay! I can see Mr. like editing me. That's super happy. Next thing you know, Mr. reappears on the camera.
It's like super loud. It's like,
Yeah, focus like yeah.
We got y equals, we got a quantity called 5 plus x squared and a quantity called x cubed minus 2x. And there are really a couple different ways you could go about your business with this thing. We could have differentiated this yesterday before we even ever talked about the product rule. You know what we could have done?
distribute. Foil.
Yeah, could have double distributed, foiled it out. We would have gotten maybe 3 or 4 terms, and then we could have just differentiated term by term. That would have been perfectly acceptable. Today, just for the sake of practice, if we want to use product rule, we could find y prime.
2x.
Yeah, that'll be part of it. So we've got our first factor in the first set of parentheses, our second factor in the second set of parentheses. So we want to do first thing just as is, right? 5 plus x squared times the derivative of the second. Well, what's the derivative of the second?
3x squared minus 2.
Good. 3x squared in the first term. The 3 comes down as a coefficient. Power of 3 drops to power of 2. Minus derivative of 2x. Plain old 2. And that's only the first part of the product. So far we've done this much of it. We've still got to do plus, and then come back the other way. This is the universal rule for come back the other way. We got to do the other half of the product rule is where you take the second factor times, times the derivative of the first. The derivative of this first term is going to be, or the first factor is 0 plus 2x, so just 2x. And it probably wouldn't be a terrible idea. We could clean this up, which means we're just going to have to foil a bunch of stuff. And we ended up foiling stuff together anyway. Darn it. I was hoping we'd skip that.
No dice.
Let's do it. So we got what, 15x squared? And minus 10? Plus 3x to the 4th. And a minus 2x squared. So far. Done all day. This is kind of nice. Then we got to distribute this in. So we get a plus 2x to the 4th and a minus 4x squared. Did I screw anything up yet? No? Well, there's still time. Yeah, so 5x to the 4th.
Yep.
No cubes.
Plus 9x squared.
Yeah, plus 9x squared, because there's 3x squared terms.
Minus 2.
Minus 10, all right. Here's your y prime.
That's the answer.
I'm afraid so, yeah. One more for good luck?
One more for Bryson.
I really like Bryson.
Right?